Now that you have an understanding of how the ignition system functions, our attention will turn to some ignition system troubleshooting. The first step in troubleshooting an ignition system is usually a spark test. For engines with CD ignition, use the spark tester specified in the engine service manual. Disconnect the spark plug lead from the spark plug and attach the tester to the lead. Attach the tester spring clip to a good ground, not the spark plug. On twin-cylinder engines, leave the other spark plug lead attached to the spark plug or securely connected to ground. Make sure all drives are disengaged or turned off and the ignition switch is turned on. Crank the engine and observe the firing tip of the tester. A crisp blue spark should be seen. If not, further testing of the system will be necessary. Testing of the ignition components used on K-Series engines with breaker point systems is covered in detail in Kohler Form TP-2210-A, titled Engine Electrical Systems. Although there are several solid-state ignition system types, some common tests can be used regardless of system. These basic steps will be discussed here. However, always follow specific testing procedures for each engine. If the ignition is not producing an acceptable spark, the next step in troubleshooting a suspected ignition system problem is to isolate the engine from the remainder of the equipment on which the engine is mounted. This is done by locating the plug connectors between the engine and the equipment. Remove the white kill wire from the engine connector. Reconnect the plug and position the connector on the white wire so it cannot touch ground. Keep in mind that on most systems, the ignition switch will not stop the engine after removing the white wire from the connector. Before attempting to start the engine, make sure all drives are turned off and the brakes are set. Locate a ground near the white wire, or have a jumper wire available to ground the white wire to stop the engine. Engines equipped with Smart Spark require a battery voltage supply to operate. On these engines, turning the ignition switch to off will shut off the voltage supply to the SAM, stopping the engine. Attempt to start the engine. If the engine starts, the equipment wiring and controls are suspected as the problem. If the engine does not start or run properly, continue to focus troubleshooting on engine systems. Continue by testing secondary leads for spark. Use the specified spark tester in place of the spark plug and crank the engine. On twin-cylinder engines, be sure both spark plug leads are grounded through testers, spark plugs, or directly to ground. The ignition modules will be permanently damaged if secondary circuits are open when cranking the engine. When cranking the engine, make sure cranking speed is at least 550 to 600 RPM when performing spark tests. If spark tests are good, but the engine starts or runs poorly, continue by replacing the spark plugs. If the spark tests indicate further ignition system problems, continue by testing the ignition module or modules. Remove the blower housing and physically inspect the modules and associated wiring and connectors. Remove and clean all terminals, including the spark plug lead connectors. Remove one module mounting screw. Make sure the other screw is silver in color and is properly grounding the module. Identify the module used on the engine you are testing and refer to the module resistance table for ohmmeter test values. Check the resistance readings between the points shown in the table. A clear coating on the magneto core may prevent the probe from reaching ground. Probe into the open screw hole to test ground. If resistance readings are not within the values listed in the table, the module is defective and must be replaced. If the module tests good, reattach all connectors. If any connectors are not tight, pinch the female connectors slightly to tighten connections. check and adjust the module to flywheel magnet air gap. Turn the flywheel so the magnet is away from the module, and loosen the module mounting screws. Pull the module away from the flywheel and snug the screws. Place a 13/1000 inch feeler gauge under each leg of the module. Turn the flywheel so the magnet is centered under the module. Loosen the screws and allow the magnet to pull the module up to the flywheel, sandwiching the feeler gauge between the flywheel and the module. Snug the module screws. Turn the flywheel to remove the feeler gauge. Turn the magnet back past the module to be sure there is no interference between the module and flywheel. Torque the screws to 35 inch-pounds. Perform a spark test to confirm correction of the problem. On units equipped with Smart Spark, further tests are available to test the SAM module. Locate the red power source lead to the SAM in the engine connector plug. Connect a voltmeter between the engine side of the connector and ground on the engine. Test voltage in both run and start. A minimum 7.25 volt reading must be observed in each test. If the correct voltage is not observed, perform normal circuit checks on both the power source and ground sides of the circuit on the equipment to locate the source of voltage loss. If all conditions checked to this point are to specification, ASAM or DSAM module testing is required. For purposes of visual clarity, we'll demonstrate tests on modules that are removed from the engine. Modules can also be tested while mounted on the engine. Disconnect all module leads before connecting the tester. Tests vary somewhat between single and twin-cylinder engines. Use care whenever connecting the tester to the module to prevent tester alligator clips from touching. Do not perform module testing on a metal bench or surface. Twin-cylinder spark advance modules may be an analog ASAM or a digital DSAM. Tester connections and test procedures vary, so the correct identity must be confirmed by checking the module part number stamped in the housing before starting tests. The term SAM will be used in cases where procedures or results are the same for either type unit. To connect a single-cylinder ASAM to the tester, follow the tester and module lead color coding scheme, matching the module lead with the corresponding tester lead. An exception would be if a green wire is used instead of black for ground, in which case the green module lead is connected to the black tester lead. Use care when connecting test leads to an ASAM that has a set of long yellow and brown leads and a set of short yellow and brown leads. Each pair will be tested separately. Connect the tester as follows. Yellow tester lead to the long yellow module lead, the brown tester lead to the long brown module lead, and the red tester lead to the red module lead. Finally, connect the black tester lead to the green or black module ground lead. The pink tester lead and the brown tester lead with black terminal end are not used when testing an ASAM. All other twin-cylinder modules are digital DSAM units. Use care to make correct connection of the long and short yellow and brown leads as described. Connect the tester to DSAMs as follows. Yellow tester lead to the long yellow module lead, the brown tester lead to the long brown module lead, the pink tester lead to the pink module lead, the brown tester lead with black terminal end to the short brown module lead, and the red tester lead to the red module lead. Finally, connect the black tester lead to the green or black module ground lead with the eyelet terminal. Note that some modules have an additional ground lead with a white stripe and a bullet connector that is used in limited applications, and all SAMs have a white kill wire. Do not connect either lead to the tester. A failed test result will occur regardless of actual condition. Recheck the SAM part number, noting the last 2 digits. Use the instruction sheet or tester faceplate table to identify which test number is to be used for the particular module. Depress the tester button repeatedly until the correct test number is displayed. Release the button. After a delay of a few seconds, the test number will flash 3 times, and the test will begin. A reverse numerical sequence, starting with a 7 or 6, will be displayed and will count down to 2 or 1, followed by a P for pass, or F if the module fails the test. If a dash or an F is displayed instead of the numerical sequence at the end of the test cycle, the SAM is likely faulty. Recheck all of the connections and the condition of the tester battery and repeat the test. If the display remains unchanged, replace the SAM. It is very important to allow 15 to 20 seconds between tests, or if the test is interrupted, for the tester to clear and reset itself. A false reading may be displayed in the form of a dash or a faint 8. If tests are being performed on an ASAM, only a partial test is complete at this stage. Tester leads must be moved from the long to the short set of module leads. The test step is repeated using the same test number to complete the test cycle for the ASAM. The SAM tester is powered by a 9-volt battery. Most SAMs are designed to operate to a minimum of 7.25 volts. Incorrect test readings will result if the tester battery drops below 7.25 volts. To periodically test the battery, connect a DC voltmeter between the red and black lead wires while the tester is connected to a SAM. Start the appropriate test sequence and monitor the voltmeter reading. Replace the 9-volt extended life alkaline battery if the voltage drops below 7.25 volts at any time during the cycle. To replace the battery, remove the outer set of 4 screws on the faceplate and carefully lift the panel from the case. When reconnecting the SAM leads, make sure connections are tight and properly sealed. SAM performance can also be checked on a running engine. Connect a timing light to one of the spark plug leads. Place a mark on the rotating flywheel screen. Start the engine. With the engine running at idle, aim the timing light beam at the screen, locating the reference mark. Place a mark on the blower housing to align with the mark on the flywheel where it is illuminated by the timing light. Increase engine RPM to full throttle. Watch the timing mark on the screen. It should move as the timing is advanced with increased engine RPM. Move the timing light to the other plug wire and repeat the prior test. The idle timing marks on the blower housing should be 90 degrees apart. If not, check the terminal connections where the yellow leads connect to the modules. Repeat the timing light test. These tests must be performed in a structured procedure for accurate troubleshooting. Also, attentive observation of all conditions and engine operation characteristics can provide valuable clues in identifying ignition system problems. The DSAI ignition system is designed to be trouble-free for the life of the engine. Other than periodically checking or replacing the spark plugs, no maintenance, timing, or module adjustments are necessary or possible with the DSAI ignition system. Mechanical elements, such as poor electrical connections, are the most likely source of ignition problems. Before beginning the test procedure, check all external wiring. Be certain all ignition-related wires are securely connected, including the spark plug leads, and the ignition switch is in the run position. The battery must also be verified to be properly and fully charged before performing ignition system testing. If an ignition problem is evaluated on an engine mounted on a piece of equipment with OEM wiring, the first step is to isolate the engine from the equipment wiring. Standard isolation procedures common with other ignition systems are applicable to the DSAI ignition. Tools required to test DSAI ignition are a hand tachometer, spark tester, part number 2545501-S, an automotive timing light, and a digital multimeter. The basic testing theory is to confirm if the DSAI is delivering spark, and if so, evaluating the timing advance performance. If the unit is not developing spark, or if the advance is not functioning correctly, the second level of testing confirms sound electrical connections to the engine wiring, ground, and the 12-volt power feed. If these factors are all within specifications, the module is assumed faulty and replacement is indicated. This process of elimination is effective in performing DSAI system diagnostics. The procedure is performed in a series of 4 tests, as described in the engine service manual. Begin by testing for spark, using the Kohler spark tester. If 2 testers are available, test both cylinders simultaneously. Observe the spark at each cylinder while cranking the engine at a minimum 550 to 600 RPM. If only one cylinder can be tested at a time, make sure the opposite spark plug wire is either connected to the spark plug or ground to prevent system damage. If both cylinders have good spark, but the engine runs poorly, or if the condition of the spark plug is in question, install new spark plugs, gapped as specified in the engine service manual. Retest engine performance, and if the problem persists, go to Test 3 in the diagnostic procedure to verify DSAI timing advance if performance is still poor. If one or both cylinders had no spark or intermittent spark, go to Test 4. Place a mark or apply a small piece of white tape to the outer edge of the flywheel screen. Connect the timing light to a cylinder with good spark. Run the engine at idle and locate the mark on the screen. Place a corresponding line on the blower housing next to the flywheel mark. Accelerate the engine to full throttle and observe the movement of the flywheel mark away from the mark on the housing, indicating spark timing advance. Repeat the test on the other cylinder if good spark was observed in the first test. The advance performance of both DSAI modules must be nearly identical, and both blower housing marks should be 90 degrees apart. If so, engine performance diagnostics should be focused on other systems. If spark advance movement was not observed on either or both cylinders, continue with test step 4. Remove the blower housing and perform a complete inspection of all electrical wiring and connections. Clean connections with electrical contact cleaner to remove all residue. Use the multimeter to test for a good connection between the black DSAI module ground lead and a known good ground on the engine. Change the multimeter to volts and leave the ground lead connected to the same point as the last test. Turn the key switch to on and confirm the 12-volt power supply at the red center module terminal. After completing Step 4 repairs, perform Step 3, the timing advance check. If the spark quality and advance are not correct, replace the affected module and retest.